Section 7.4, the first part, is finding the LCD of rational expressions. We've already said that rational expressions are fractions, and so the LCD you need to remember is the least common denominator. Common denominators are important when we're adding and subtracting fractions, you'll remember, and that's what we're going to do next time. So last time we added and subtracted fractions, but they already had common denominators. But what if they don't? Because you know, in the real world, it's not always easy. So what happens if you have two fractions that don't have the same denominator? We're going to have to find it, and I have some easy sneezy steps to follow. Here we go. To find the LCD, step 1, you're going to write the prime factors of each denominator. So in this case, 8 is 2 times 4, and 4 is 2 times 2. So the common factors of 8 are 2 times 2 times 2. And then the prime factors of 12. 12 is 3 times 4, and 4 is 2 times 2. So now what we're going to do is when we write the factors of the 12, we're going to match up, kind of like we did when we found the greatest common factor. We're going to line up the ones that are the same. So we've got two 2's, so we're going to line those up under these 2's, and we've got a 3 that is not the same. So we're going to have that separated out. Now for step 2, so that's step 1, write the prime factors of each of the denominator. Now, number 2, we're going to use one of each different factor. Now, that's different what we did before. Before, we only took the ones that match. For the least common denominator, we have to have one of every factor involved, but we don't have to duplicate them. So that's why we matched them up. So what we're going to do is this. We're going to take a 2 from this column, a 2, another 2, and now a 3. So we're going to take one of each different factor, and that's why I said see the example so you know what I mean. Take one of each different ones of the factors, and so if there isn't a match, we want that one. If there is a match, we want that one. But you don't have to have this 2 twice. Does that make sense? Okay, so then your last step is just to simply multiply the factors together. So 2 times 2 is 4, times 2 is 8, and 8 times 3 is 24. So in this case, the LCD is 24. All right? Let's do the same kind of thing if we've got x's involved. So I know that 4 is 2 times 2, and x squared is x times x. And 6 is 2 times 3, so I'm going to put the 2 here. Let's put the 3 here so it's not lined up with anything. And x cubed is x times x times x. So now, when we find the least common denominator, it's going to be the smallest one that has all of these involved. So I've got a 3, I've got a 2 and a 2, and I've got 1, 2, 3 x's. So the LCD here is 3 times 2 is 6, and 6 times 2 is 12. X, 1, 2, 3 of them, 12x cubed. Easy sneezy, right? No problem. All right. If you've got binomials, so that's with monomials, it's easy. Make sure that you find all the prime factors of your constant and then spread apart all of the factors of your variables. Now, if you've got a binomial, remember if there's a plus or a minus in here, you can't just do the factors of the 5x and the factors of the 15. It doesn't work that way because all of this together is one number. Okay, this binomial is together. So what we have here is we're going to have to factor out the way you've learned how to factor out binomials. There's a 5 in common with both, so you're going to pull out the 5, and what's left now is x minus 3. All right, and now with this one, there's a 2 in common, so you pull out the 2, and what you have left is x minus 3. So then, when you list out your factors, you're going to list, you've got 5 times x minus 3, and you've got 2 times x minus 3. So that x minus 3 is in common. We don't need to have it twice, but we do need a 2 times a 5 and an x minus 3. So our LCD in this case is 2 times 5 is 10 times the x minus 3. And you can leave it factored out that way. All right, it's going to be easier if you leave it factored out, because in the end, after you add, you may need to cancel some things. You may need to simplify your fraction. So leave your LCD in a factored format so that you can use those factors. All right, one more of this type that looks scary, but it's not really. It's the same kind of thing. What you need to do is the step one is to write the prime factors of each denominator. So we need to know what are the factors. So you need to factor it out. And remember, if you've got a trinomial, to factor it out, you're going to do your 2 parentheses and make it into 2 binomials. So x times x is x squared. The signs are the same and the signs are positive. 5 times 5 is 25 and 5 plus 5 is 10. So we're good there. And 6, let's see, what's in common here? Oh, 6 is in common between 6 and 30, so we can pull a whole 6 out. And x cubed, there's 3 of them in common. 6x cubed, and there's 1 x left here. And we don't have any x's left, but we do have a 5 here. All right. So now what you can do, if you want to line them up over there, you can. But sometimes when you've got binomials, it's really easy just to see. You've got an x plus 5 in common, but one of them is extra. So what you can do is just over here, put this x plus 5 under this x plus 5. So now you can see your LCD is this 6x cubed times, now x plus 5 times x plus 5, remember, is just x plus 5 squared. So you can just put a squared on that. And that is your LCD. Now, this is the first step of what you're going to do. So in your homework, all of the problems are going to say, I want you to find the least common denominator between these 2 fractions. So step 1 is just to find the least common denominator. But then after you find that least common denominator, you're going to put those into fractions. Put those fractions into fractions that have like denominators. So the first step of doing that is just to follow the steps to find the LCD, which is what you just did. We just found the LCD, so step 1 is done. After you find the LCD, in order to get fractions that have like denominators, you're going to need to multiply each numerator by the factors that are not already in its original denominator. Okay, kind of pause and let that sink in. So after you find the least common denominator, what you're going to do is you're going to look at your denominators and find out what factors are not already in this denominator. And then you'll multiply the numerator by that. Because, let me show you on the ones like you've done before. If your common denominator is 24, to get to 24, you multiply this 8 by a 3. So here was the 8. And there's a missing number here. We multiplied by a 3. So you multiplied this 8 by 3 to get 24. So to keep your fraction equivalent, you got to multiply the top by the same thing. Well, when I said 2 instead of 3. So you multiply the 1 times 3. So 3 over 24 is equivalent to 1/8 because we multiplied the top and the bottom by the same thing. So we've really only multiplied it by 1. In essence, what we've done is we've just chopped those pieces into smaller pieces. All right. So 7/12, if I want that to be a fraction with a 24, my least common denominator on the bottom, I look and I see, well, 12 was 2 times 2 times 3. And so a 2 is missing, so I need to multiply my numerator by 2. And so 14 over 24 is my equivalent fraction to 7/12. All right, so hopefully you remember how to do that with the numbers, and so I'm just going to add in a little bit of a tweaky thing to get your variables. So now with 3 over 4x squared, we said our least common denominator is 12x cubed. So I want both of these fractions to have a denominator of 12x cubed. All right. So in order to get from 4x squared to 12x cubed, go back to your chart. 4x squared was this row here. And the things that are missing are a 3 and an x. So you need to multiply this by 3x. So 3 times 3 is 9, times x is 9x. And now you have a fraction that is equivalent to 3 over 4x squared, but it'll have the same denominator as this one. And then the same thing here, 6x cubed was this row. There's our 6 and there's our x cubed. And what's missing here is just this 2. We've got a 2 missing in this factor, or in these factors. And so you're going to multiply the top by 2. And so 10 over 12x cubed is a common is an equivalent fraction. All right. These get a little bit trickier, but not extremely so. 10, so my denominator, I didn't make enough space. 10x minus 3 is our denominator. And this is why it's handy to keep it factored, because then you can see, what am I missing? Because we had 5x minus 3 already. And so 5x minus 3 we have, so we just need a 2. So you need to multiply this by 2. So 7 times 2 is 14, and there we're done. All right, so with this one, we had 2 times x minus 3, so the 5 is what's missing. We had the 2 and the x minus 3 here. This 5 is missing, so times 5 is 25. All right, is it kind of coming? Last one, here we go. So now, on this one, our common denominator is, oh boy, I didn't give myself enough room at all here, is 6x cubed times x plus 5 quantity squared. And the same thing here, 6x cubed times 5, oh no, x plus 5. X plus 5 quantity squared. Can you see that? All right, so when I factored this out, I know this is x plus 5 times x plus 5, which is the same as x plus 5 squared, right? So the extra part is this 6x cubed. So if I multiply the top by 6x cubed, because I multiplied the bottom by 6x cubed, my fraction will be equivalent to what it started out as. So now 7 times 6 is 42. Oh, and then, oh, we don't have to have, we can put a parenthesis around it, but we don't have to. 42x cubed. All right, and then this one, we took 6x cubed times x plus 5 was this denominator. So what we're missing is just another x plus 5. So you can just leave this 17 times x plus 5. You could leave that just like that, or you can multiply it through if you wish. But for now, I would suggest just leaving it, because then after you combine, then is when you'll finagle the numbers and decide whether or not you need to multiply it out or just leave it. All right. So for now, you can just leave those factors there. If your factors are numbers, are constants, then go ahead and multiply those. But if your factors are binomials, then just leave them. All right? No problem, right? Find the LCD. First, go through and find the LCD. After you found the LCD, then come up with equivalent fractions that have that LCD that you found. All right? I'll see you next time.